So far we have done stoichiometry, all of the calculations that you can get. Now we're moving on to complex stoichiometry calculations, which is almost the same as normal stoichiometry, just there's one extra step that you're going to have to do before you carry on with all the calculations. So it's here on page 182 of your textbook. Right, now when it comes to stoichiometry, the complex version of it, there's only two extra things that we have to know. The first thing is what we call the excess reagent. Another word for reagent is just reactants, so it's what you normally know about reactants. And the second one is what we call the limiting reagent, or sometimes I just write LR for limiting reagent or reactant. Now, in a formula or a chemical reaction, you know that you're going to have reactants or reagents, and those will be turned into products. Now, you're going to get one of those reactants, which is called the excess reagent, and the other reactant is going to be the limiting reagent. Now, excess reagent, it just whatever the name means. Excess means when you have too much of something. So the reactant which is in excess means that reactant you have too much of it. And the limiting reagent, or LR, is the reactant which gets completely used up in the reaction. Okay, so you have the one that is too much, and then you have the one that is just enough, and that one gets completely used up. And because the one that is in excess is too much, it means at the end of the reaction you're going to still have some left over. For example, if you are making, let's say you're making a cake and you have all your ingredients, you have sugar, butter, flour, all of those things. Now let's say your recipe says you must use 4 cups of flour and 2 cups of sugar, and you only have 2 cups of sugar, but you have 5 cups of flour. So it means the sugar is the limiting reagent because you have 2 cups and you need 2 cups, so you're going to actually use up all of those 2 cups. But flour, you only need 4 cups, but you have 5 cups, which means you have 1 cup extra, and you're not going to be needing that 1 cup extra. So the flour will be in excess. So the same thing in chemical reactions. You have a reactant that is in excess, which will not all be used up. It will be extra at the end of the reaction. And then you have the limiting reagent, which gets completely used up because you just have enough of it. Now, the important thing about this limiting reagent is that the limiting reagent will determine how much product you make. Because if you have just enough of limiting reagent, it means you're going to form however much product can come out of that amount of limiting reagent. So all of your calculations that you're going to do will be based on the limiting reagent, not on the excess reagent. Okay. Now, they are not going to tell us when we're doing a test or exam which reactant is in excess and which is the limiting reagent. We need to figure out which one it is. Now there is steps to follow to see which one is the limiting reagent, and we put more emphasis on the limiting reagent because this one is more important, and this one is the one that we're going to use for all the calculations that we're going to do after this. Right, so the steps that we use to see which one is the limiting reagent is, firstly, we have to have the correctly balanced chemical reaction. So in any stoichiometric calculations, you need to make sure you have a chemical reaction which is correctly balanced. The second thing is, you are going to calculate the moles of all of the reagents or the reactants. So if you have 2 reactants in that chemical reaction, you have to calculate the moles of all of them. If you have 3, you're going to calculate the moles of all 3 of them. And the way you calculate moles is the same like how you do normally. If you're dealing with mass, you'll use the mass formula. If you're dealing with concentration or volume or particles, you'll use whatever formula that matches with that. Right, so after you calculate the moles of all your reagents, you are going to take that mole and you are going to divide it by the coefficient in the reaction. Now, when you balance the chemical reaction, you know you're going to have coefficients in front of the reactants and products. So you're going to take that moles of the reactants and divide it by the coefficient in that reactant. And then whichever one gives you the smallest number, that one is the limiting reagent. So this is the step you need to follow to see which one is the limiting reagent. And the smallest number will give you the limiting reagent. Okay, and then once you find out what is the limiting reagent, you can then use that moles to work out all of the other things like the ratios and all of the moles of the products, which you need to do like in normal stoichiometry. So the only way that this differs from normal stoichiometry is that before you can do any calculations and ratios and moles, you need to first work out which one is the limiting reagent. Okay, now the best way to understand this is to do examples. So let us do example 28, which is on page 183 of your textbook. Right, so you can follow along with me with your textbook. So you're going to have here 2 CH3OH plus 3 oxygen molecules, giving you 2 carbon dioxide plus 4 water molecules. Now in this question, they said that you're going to have 40 grams of methanol, which is CH3OH, and 46 grams of oxygen. Now here they're asking us to find out which one is the limiting reagent. Now before we can do any other calculations, we need to make sure we get the limiting reagent right, because if we don't, all our other calculations is going to be wrong because it depends on that. So the first step to finding limiting reagent is calculating moles of all of the reactants. So here we only have 2 reactants, so we're going to calculate the moles of both of them. And as you can see, the reaction is already balanced, and it's actually correctly balanced, so make sure you do that first. Right, so let us start with methanol. So you have here the moles of methanol, which is CH3OH, and because they gave us mass, we're going to use the mass formula, which is small m over big M. Right, now the mass they gave us is 40 grams, and we're going to divide it by the molar mass, which you can calculate. It will be 32 grams per mole, and that will give you moles of 1.25. Right, so you have 1.25 moles of methanol. Okay, now let us do the moles of oxygen. So you have moles of oxygen is equals to small m over big M. Again, because they gave us mass, so you're going to say 46 divided by oxygen, which will be 32. Now remember that oxygen is diatomic, so each oxygen is 16, but since you have 2 oxygens, it's 16 times 2, which is 32 grams per mole. And when you're using these formulas, you never ever put the coefficient into this formula. So you ignore that 2 in front, you ignore that 3 in front. Okay, and that will give you moles of 1.44. Right, so after we work out the moles of each of the reactant, we're going to take each of the moles and divide it by the coefficient. Now, if we're looking at methanol, the coefficient here is 2. So I'm going to take this 1.25 moles, divide it by 2, and that will give you 0.625 moles. Okay, so this is the moles you get after you divide it. And then you're going to do the same with oxygen. You're going to take 1.44 moles and divide by the coefficient. And for oxygen, the coefficient is 3. So you're going to divide it by 3. And that will give you 0.48 moles. Now, after you do this, all you need to do is see which one is smaller, and that one will be the limiting reagent. So between 0.625 and 0.48, obviously 0.48 is smaller. So oxygen or O2, this one is the limiting reagent. Right, and that's how you get it. So again, all you have to do is work out the moles of each reactant. Once you get that moles, divide it by the coefficient. The one that gives you the smaller number is the limiting reagent. Okay, the next question, 28.2, they're asking us what mass of carbon dioxide can be produced. Now, carbon dioxide is the product here, and we have to find out how much mass of carbon dioxide is produced. Now, remember, we said that all calculations you do will be based on the limiting reagent. So the one that is in excess, we're going to ignore it. And the limiting reagent, we're going to use those moles as a ratio for everything else. So we found out from here that oxygen is the limiting reagent, which means that methanol, the other reactant, this one is in excess. Right, so this one is in excess, and oxygen is the limiting reagent. Now, because oxygen is limiting, we're going to use oxygen for all the calculations we are going to do now. So to get the moles of or the mass of carbon dioxide, we're going to use the same steps which we follow in normal stoichiometry, which is number 1, work out moles, number 2, ratio, number 3, moles again, and then lastly, we work out the mass. Now, we already worked out the moles in the first question, so we basically have one step less to do. Right, now if you're looking at the ratio between oxygen and carbon dioxide, can you see that you have 3 oxygen is to 2 carbon dioxide? Right, so however much oxygen you have, carbon dioxide will be 2 times of it, and oxygen will be 3 times. Now, when we are using the moles of oxygen, we are not going to use the moles that we have after dividing it by the coefficient. Right, let me just say that one more time. When we're using the ratio, we are not going to use the moles that we have after dividing it by the coefficient. So we will use the moles that we had before dividing it by the coefficient. So when we worked out the moles of oxygen, we just said the mass over the molar mass give you 1.44 moles, and this is the moles we had before dividing it by 3, which is the coefficient. So we're going to use 1.44. We're not going to use 0.48. Right, so we're going to say 1.44 moles of oxygen is to the moles of carbon dioxide. So we don't know how much it is. We just know that this is going to be a ratio of 3:2. Now, when we have this ratio of 3:2, you're going to cross multiply. So you're going to say 1.44 divided by 3, which comes from here, and you're going to multiply it by this 2, and that will give you moles of carbon dioxide, which is 0.96 moles. So this is just the normal way how you do it with normal stoichiometry. Right, so now that we have the moles of carbon dioxide, we can just go get the mass, and we're going to use this formula. N is equals to small m over big M, and we have the moles, which is 0.96. Small m is what we're looking for, and the molar mass of carbon dioxide is 44 grams per mole. So that will give you a mass of 42.24 grams. Right, so all of the steps we followed is exactly the same like what you were doing all this time. The only thing is that we use the limiting reagent as the ratio, not the one in excess, and we use the moles that we had before we divided it by the coefficient, okay, which will always be the bigger number. So basically just use the bigger moles. Okay, let's move on to the next question. The next question says, what mass of the reactant that was in excess was left over after the limiting reagent has been used up? Now, they're asking us what is left over of the one in excess. Now, the one in excess is methanol. We worked that out from the moles. So we have to see that after this reaction happens, how much of methanol will be left over. Okay, so before we can find out how much of methanol there was left over after the reaction, we first have to work out how much methanol was used in the reaction. So to do that, we're going to use again ratios like how we normally do. So if you look here in the formula, you have 2 methanols is to 3 oxygens. So let us use the ratio. So you have, this is 2 methanols is to 3 oxygens. Right. And now, since we're dealing with oxygen, we're going to also use the moles of oxygen that we used in the previous question, which is, again, the moles before we divided it by the coefficient. So that's always the bigger moles, which is 1.44. Right, so oxygen moles is 1.44. You will use this from your calculations of limiting reaction, right? And then, to get the moles of methanol, we're going to cross multiply. So you're going to say 1.44 divided by 3 times 2, and that will give you moles of 0.96 of methanol. So that means in the reaction you used 0.96 moles of methanol. Now, from the first question that we did, where we were trying to determine which one is the limiting reagent, we saw that working out the moles of methanol, we actually had 1.25 moles of methanol, and that was excess. And in the reaction now, we see that we only used up 0.96. So if we had 1.25 and we used up 0.96, it means we still have some left over, which just proves that methanol is the one in excess. So to get how much is left over, we're going to take the total amount of methanol, which was 1.25, minus the amount that we actually use in the reaction, which is 0.96, and that will give you 0.29 moles. Now this 0.29 moles means however much moles was left over of methanol after you did the reaction. So this proves that methanol, because you had left over, it is the one in excess. But you won't have any left over of oxygen, because oxygen is the limiting reagent, so it will get completely used up. Now they're asking us in the question for the mass that was left over, and obviously we just worked out the moles. So to get the mass, we're going to use N is equals to small m over big M, because this is the mass one, and we're just going to substitute. So you're going to put the 0.29, because this is how much is left over, is equals to small m over big M of methanol, which is 32 grams per mole, and this will give you a mass of 9.26 grams of methanol. So it means after you did the reaction, after everything was done, all the reactants turned into products, you had leftover of 9.26 grams of methanol. So that was what was in excess. Right, let's do another example just so you can get more understanding of this section here. Right, so we're doing example 29 on page 184 of your textbook. So here we're dealing with acid and base reaction. So you have barium hydroxide plus HBr giving you barium bromide plus water. Now in this chemical reaction here, they told us that in the beginning you have 0.25 grams of barium hydroxide and you have 14 centimeter cubed of a 0.125 mole per decimeter cube solution of HBr. So again, we have to find out the limiting reagent. That is the first question. Okay, now to find out limiting reagent, again the steps is you work out the moles of each reagent and then you divide it by the coefficient. Whichever one is smaller, that one is the limiting reagent. So let's start with barium hydroxide. Let's work out the moles of barium hydroxide. Now since they gave us mass of barium hydroxide, it means we have to use the formula N is equals to small m over big M, because that's how you work out moles from mass. So it's going to be moles of barium hydroxide is equals to small m over big M. Small m is 0.25 molar mass. You guys can calculate it. It will give you 171 grams per mole, and that will give you 0.0015 moles of barium hydroxide. Okay, so now let's work out the moles of the next reagent, which is HBr. And remember, when you're using this formula, you do not include the coefficients. Coefficients are not included in these formulas for moles. Right, so again, now when you're using this one here for HBr, can you see they did not give us mass? They gave us 14 centimeter cubed, and whenever you see cubed, they're talking about volume. And they also gave us 0.125 mole per decimeter minus 3, which is concentration. So in this case, we can't use the mass formula because we don't have mass, but we do have volume and we do have concentration, which means to work out moles, we have to use this formula, N is equals to CV. And just remember that volume is always in decimeter cubed. So since they gave us centimeter cubed, we now need to convert this into decimeter cubed. Right, so let us use this formula. So concentration they gave us is 0.125. Volume is 14, but to change it to decimeter cubed, you multiply by 10 to the minus 3. So it will be 14 times 10 to the minus 3, and that will give you an answer of 0.0018 moles of HBr. Right, so now that we have the moles of each reactant, we are going to divide it by the coefficient, and then from there we can see which one is the limiting reagent. Now, in this formula here, barium hydroxide has a coefficient of 1. So obviously, if we multiply this moles by 1, it will give you the same answer, which is 0.0015 moles. Okay. And then for HBr, it has a coefficient of 2. So we're going to take this moles and divide it by 2. And that will give you 0.0009 moles. Now, after you divided by this coefficient, we have to see which number is the smallest, and that one will be in excess. So if we're comparing 0.0015 to 0.0009, obviously 0.0009 is smaller, so this one will be the limiting reagent, and this one is HBr, which means HBr is the limiting reagent. And if HBr is the limiting reagent, it means that barium hydroxide is the one in excess. Okay, so now we found out the limiting reagent, and from here we can work out, or we can calculate everything using the moles of the limiting reagent. All calculations must be based on the limiting reagent. Okay, so the question actually asks what mass of barium bromide can be formed. So they're asking us what mass of this product is going to be formed. So now that we found out the limiting reagent, we can use this moles to work out the mass of this. And from now, you can just use the normal steps of stoichiometry, which we have been using all the time. So we have the moles of this HBr. So what we need to do now is use the ratio. So if we look at the formula, we have a ratio of 2 HBr is to 1 barium bromide. So I'm just going to write the ratio here. 2 HBr is to 1 barium bromide. Right, now when you're using the ratio or the moles, remember that when you worked out the limiting reagent, you had the moles of the limiting reagent, and then you took that moles and you divided it by the coefficient. Now when you're doing calculations, you are not going to use the value of moles which you got after you divided it by the coefficient. You are going to use the one you had before you divided it, which is the first one, and that one will always be bigger than the second one. So as a rule, just use the bigger number that you have for moles of the limiting reagent, and in this case it's 0.0018. We're not going to use the one after we divided it by 2. So HBr will be 0.0018, and this is going to be a 2:1 ratio, which means however many moles of HBr you have, barium bromide, you will have half of it. So 0.0018 divided by 2 will give you moles of barium bromide of 0.0009 moles. So this is how much moles you have of barium bromide. Now that you have the moles, the next step is just to work out the mass, and that's the easy part. For mass, you're going to use the formula N is equals to small m over big M. Then you just have to substitute. Moles is going to be 0.0009. Mass is what we're looking for. Molar mass of barium bromide is 297 grams per mole, and that will give you a mass of 0.27 grams of barium bromide. Right, so if you guys can notice, stoichiometry, all of the steps of moles, ratio, moles again is all the same. The only thing that's different is working out the limiting reagent before you do any of those things. And when you're using the ratio, you need to use the moles before you divided it by the coefficient.